4.8 is on composition of functions. We're going to spend 2 days on this, so today is day 1. Okay, so composition of functions. I'm going to start with the word problem so you can kind of see what a composition is. So in a composition, sometimes you need 2 or more problems or 2 or more functions to describe a problem. So suppose an offshore oil well is leaking. Graph A here shows the radius of the oil leak over time, and graph B shows the area as a function of the radius. So we need the radius to find the area. So first we would do the first function. So for example, in the first function, let's say after 4 hours, the radius is 1.5. So then using that information, we're going to take that output value, we're going to stick it in for the input value of graph B. So if the radius is 1.5, then the area would be 7. So a composition of functions is using substitution to do one first to get the answer, and then plug that answer into the second function. So it's basically substitution. Do one function first, plug that answer into the second function, and then do the second function. So composition means composed of more than one, and here composition of functions will be more than one function. Okay, so there's a real life example of where you might see a composition of functions, where you have to figure out the radius first, and then you can figure out the area of the oil spill. So you might see a composition written like this, and we've had g of x before, we'd have f of x. So when they're overlapped like this in a composition, we read this f of g of x. And basically all it means is find g of x first, so it's kind of like using order of operations. Do the inside one first and use that answer to find f of x. So let's just do some examples here with numbers first, and then we'll do it with letters. So here we have 2 functions, f of x and g of x. We know how to do f of 3. That just means plug in a 3 for x and solve. So let's try that quickly. So this is review when we first started functions this unit. So f of 3 means plug in, use the f function, and whenever you see an x, plug in a 3. So we have 3 plus 1. So we get the square root of 4, which equals plus or minus 2. So there's 2 answers there. We'd say f of 3 equals plus or minus 2. Okay, but what happens if you see this composition of functions? Use order of operations. So first step is we would do g of 10. That's telling us to plug into the g equation at 10 for x. So we get 10 minus 2. We have g of 10 equals 8. Okay, now we're going to take that answer. G of 10 equals 8. I'm going to replace this whole thing with an 8. So step 2 here is let's find f of 8. Okay, so we're going to plug in an 8 into this right here. So we get the square root of 8 plus 1. We get the square root of 9. And you get 2 answers, plus or minus 3. So your final answer, f of 10 equals plus or minus 3. Okay, so basically it's just doing 2 problems. Okay, so you have to do the first one first to get that answer. You got 8, then you plug it in for the second one and get that answer. So that's the composition of functions. There's one more, g of f of negative 1. So let me write that up here because it gets cut off. G of f of negative 1. Okay, so first step, start with the inside, f of negative 1. We're going to plug in a negative 1 plus 1. We get the square root of 0, which is 0. Okay, so we have f of negative 1 equals 0. Step 2. Replace f of negative 1 with a 0, so we get g of 0. Plug in, it just means 0 minus 2. So we say g of 0 is negative 2. So that's our final answer. We can rewrite it like this. G of f of negative 1 equals negative 2. And it just means I plugged in a negative 1, got an answer. I plugged that answer into the g function and got negative 2. All right, well, what will a graph of a composition look like? Okay, so y equals g of f of x. Let's write down g of f of x. What this means is plug in f of x into your g function. So this will be the absolute value of 1/2 x minus 2. Alright, if you don't have a graphing calculator, you can make a table with x and y values. Pick some points, plug in, like -2. Plug these values in for x, and you can get your y values and graph. If you have your graphing calculator, you can type that in. So let's practice typing it in. You're going to go to your y equals. Let's clear out what's there. Absolute value on these lines right here is under the math menu. So go to math, go over to number, and absolute value is the first one. So there it is, hit enter. And 1/2 is the same as 0.5. So you can either put 1/2 in parentheses or just write 0.5. 0.5x minus 2. So let's graph that. There it is. As you can see, the slope of this absolute value is 1/2. And the minus 2 was in parentheses, and so that shifted your graph. Looks like it shifted it, well, more than 2 to the right, but it is shifted to the right there. Okay. So there's a composition of functions for a graph. Okay. Composition versus product. What is the product and what is the composition, and are they the same? So composition is doing one first, using that answer to get the next. So do one function, get an answer, use that in the second function. A product means multiply. So product, you're multiplying the functions. Are they the same? So let's try it. What is the product? Let's do product first. Product is 2x minus 4 times x minus 1. All right, let's multiply. These are called binomials. There's 2 terms in each. So you can either FOIL or use a rectangle to multiply them out. Or I'll FOIL. So we get 2x squared minus 2x minus 4x plus 4. Combine like terms, so we get 2x squared minus 6x plus 4. So there's the answer for the product. Let's do a composition. So f of g of x means to plug in g of x into this x right here. So that will give us 2 times x minus 1 minus 4. So we'll multiply. We'll get 2x minus 2 minus 4. I'll get 2x minus 6. Are they the same? And you can clearly see no, they are not. Okay, we're just going to practice a couple more. And then tomorrow we'll have a second day on this, a second day in compositions. All right, so check for understanding. Find f of g of negative 3. So first start with g of negative 3. We have the absolute value of negative 3 minus 1. So g of negative 3 equals the absolute value of negative 4, which is 4. All right, now take this 4, plug it into your f function for g of negative 3. So second step, we have f of 4 equals 4 squared plus 6. So we'll get 16 plus 6. And so that'll give us 22. So we can say f of g of negative 3 equals 22. Let's try another one. Let's try, how about f of g of x? Alright, so what does this mean to do? It means plug in. Actually, let's do, okay, we can do it. We're going to plug this in right here. So f of g of x would be x minus 1 squared plus 6. We can go the other way too. We can do g of f of x. So now we're going to take the f and plug it into here. So we get the absolute value of x squared plus 6 minus 1. So here's plugging a function into another function. And again, we'll practice this more tomorrow. Okay, so here's your assignment. In class, we're going to do 2 together. Go ahead and skip 8, 10, and 13. Try the rest. And tomorrow will be day 2 of functions, composition of functions.